Yep. Good evening, everyone. Let's start off. Switch on your cams. So last class we have done some basic math, polar coordinates, and all that stuff, and we have started with the vectors. So we just started a little intro on vectors, so we didn't do anything much. So other scams on. Great. Last a minute. Let me just take the attendance. Okay. Great. So okay. So if there is anyone, I think there are one person who is new for the class. Again, just to repeat few things, like, don't worry about writing the notes. You'll get the PDF. So focus on listening, understanding, solving the questions, right? You got any queries, any doubts, you can always, unmute and ask. But if I give you a question and you want to answer, you can please type in the chat box so that others also can try, right? So that's it. So that is one thing. So last time we did this, so we defined what something called a physical quantity. So it's any quantity that can be measured and observed in an experiment, like force, mass, energy. We don't deal with things like fear, hunger. Now, if you see, these things are non-physical quantities. You can observe them, but you can't measure them. You can't give a number. You can't tell how much are you scared of a dog versus how much of you scared versus a snake. Like, you can't tell snake is 10 times more scary than a dog. What if you're a snake lover, right? What if you like snakes? So it depends. So then we said physical quantities can be classified into scalars, vectors, and tensors. Tensors we don't have in the portion, so we'll not touch them. Scalars and vectors are the two things. So scalars are simply quantities which can be defined with magnitude, whereas vectors which have magnitude, right, they need direction and they also have to obey something called vector laws. So what are these vector laws and everything? We'll talk about it. So before going ahead, little more context here. Now, if you look at current has both magnitude and direction. So for example, see, if you take a force 10 Newton and a force of 10 Newton, meaning if someone is pushing you 10 Newtons from the right and 10 Newtons from the left, what will be the net force acting on you? The net force will be zero, right? But what if someone is sending a current of 10 amperes from the left and 10 amperes from the right? Then what will be the total current that comes out from the wire? It's not zero, right? It's 20 amperes. So this is what I was saying. It doesn't obey Vector's law. Unlike forces which cancel out, currents don't cancel out. So this is what you mean by Vector's law. As simple as that. So I give a simple example there. So current is not a vector. So net current is 20 amperes. So current does not obey Vector's laws. It's not a vector. Similarly, area is a vector quantity. Now, if you guys remember, I told you vectors, right? This chapter is completely made by us. If you go to around 1900s, right, meaning 90, 92, 90, 95, during that time, there was no chapter called vectors before this. My maths teacher who taught me maths, right, in 11th and 12th, didn't know vectors. Because at his time, there is no concept called vectors only. People were using it, but there is nothing formalized as a vectors ka chapter. So this thing is something little recently made up. So people made up this chapter, because it's useful and it's quite convenient. So people said defining area as a vector is more useful than leaving it as a scalar. Now, how is that done? Simple example, think of like this. Let's say we have a room and we have a door. At the door, we have a sensor. So this sensor, right, simply counts when you cross the door, the sensor gets activated. Now imagine area of the door if you treat it as a vector. Now if 10 people enter inside and 5 people come outside, what will the sensor show you? When 10 people go inside, it will count to plus 10. When 5 people come out, it will count plus 5. It will simply say 15. So the sensor is simply counting the number of people crossing the door. What if you're standing at the door, you're jumping inside, outside, inside, outside, inside, outside, then what will happen? The counter will simply show plus one, plus one, plus one, plus one, plus one, isn't it? Really not a useful data. But if you define like this, anyone who comes out of the door is positive or negative, and anyone who enters the room is positive. So if you define a direction for the door, now what does the sensor do? If 10 people enter inside, it will show plus 10. If 5 people go outside, it will say minus 5. It will tell you the net amount of people that have entered the door. And now if you stand here and jump in, out, what will it do? It will do plus 1, minus 1, plus 1, minus 1. Can you see? It's little more useful than defining it as a scalar. So people said, yeah, defining area is better, right? And we will see later on in physics, it keeps popping up multiple places. So we'll not worry about it, but it does come. So defining area as a vector is more useful than leaving it as a scalar. So how does the direction is defined? The direction is defined perpendicular to the plane. So don't worry about it. We will do it in more detail later on. So we can take it as up or down. Any direction is fine. So for plane surfaces, we choose the perpendicular direction as the direction. We choose a vector perpendicular to the plane. You can choose any one. But if you have closed boxes, this concept, right, we use extensively in 12th standard. For closed surfaces, we use outward normals as positive. And so we come out of the box, we take it as positive, just a convention. And for example, if you got a cube, or if you got a sphere. So we treat this is positive, this is positive, 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 and positive. For a sphere, these are positive, like spikes. So the overall thing is this: current has a direction, but it is not a vector. Area looks like a scalar, but it is a vector. Clear this? So that's this whole page. That's what it's trying to tell. But don't worry. As we go ahead, we will do more on this. Any doubt so far?
Sir, can you please summarize what did you teach? Because there was some technical issue from my side. So can you just
Yeah,
summarize?
you can wait till the end. We will see in the end. Yeah. Can you just keep your cam on? Yeah. Let's see. There's nothing there. Just did a little theory there. You can stay back in the break. I'll teach you. It's really not that related to the next part. So don't worry. We will see that in the end. If it was related, we would have done it. Next thing. Um okay. Drew, can you keep your cam on? Representation of a vector. So great. How do we define this vector? So there are few ways to define this. The first thing is your pictorial representation. So what do you nothing? It's a direct picture there. Dhruv, are you there?
Yes, sir, but this
Your,
laptop, this is
your
another,
cam is your cam is not working.
yeah.
Okay, ठीक है. At least leave me a message, na. No problems. Get it sorted next time, okay?
Yes, yes.
So pictorial representation, right? So in this, what we do, we just draw a picture. So we just show a vector with an arrow. So this is the body, this is your head, and this is your tail. So three things there. So here the head gives the direction. Vectors are very important. Literally, they'll come in every chapter. So this is like, what do you call? What do we say? In every curry we put some onions. It is something of that sort. Vectors is like, you should know. And the length of the body represents the magnitude. So the bigger the line, the more the length. The length of the body is proportional to magnitude. Right? So example, a bit of a theory. So if you say this length is 1 unit, then the 2 units should be exactly double of that. Just a convention there. So most of the times we draw pictures like this. So there is another way to represent this. We use something called a symbolic representation. Right? You can represent something with a picture, you can represent something with a symbol. Right? So if someone just writes A, means it's a scalar. For example, someone say like this thing, the quantity A is 2. Matlab, when you say like that, right, it is understood you're talking about a scalar quantity. A mass M is 2 kgs. But if someone says A bar, this is how we pronounce this, A bar. You can look at the arrow on the top. So if someone writes this, it's a vector. So if someone writes a thing like this, a quantity A bar is equal to, so it is understood. The moment you say bar, this guy is talking about a vector. Then we have something called a cap. So this is called a cap. You put a cap on the top. This is called a unit vector. What's a unit vector? It's a vector whose magnitude is 1. Right? So these things, right, they give the direction of the vector. So these vectors give direction. We'll talk about that again. Don't worry, I'm just giving you all those things together. So these give direction. For example, think of like this. If I say a person has walked a 20-kilometer east, which way did he walk?
ब्लॅकच घालायचं असतं त्याला असं
East,
घालायचं
right?
असतं तसं घालायचं असतं परत हे घालून त्याला खेळायला जायचं असतं जेणेकरून ते खाली
Someone needs to keep the mic on mute.
कितना लेंगे
Yeah, perfect. Tejasvi, can you keep your cam on? Guys, you need to make sure your cams are on. Matlab, next time, I know there are some issues with the cam, but please sort it out. You can always get a camera from Blinkit. They'll give you in 20 minutes. It'll cost some 800 rupees. Right? Because if your cams are not on, I'm not going to keep you in the class. Maybe for now it is fine today, but next time, please do make sure cams are always on. Until unless something really happened, your brother has taken your laptop and smashed it and yours gone. I can understand, but let's hope something like that doesn't happen. Right. So this give direction. So if someone says I walked 20 kilometers east, which way did I walk? I walked east. What east? 1 east, right? That's it. That's the magnitude of 1. And so if someone writes mod a bar, so again, this is how it's pronounced, mod of a bar. So this gives you the magnitude. So these are the 4 symbols we keep using repeatedly. You should know. So if you put the 2 lines on the side, suddenly you get a magnitude of a vector. It tells you what is the magnitude. So if I say mod of 20 kilometer east, means it is 20. I don't care about east, west, anything. It's simply the mod. Clear with this? So this is the second way to represent this. Any doubts on this? All clear? Standard stuff? So that's how you represent with symbols, and that's how you represent with pictures. Dhruv, clear? Dhruv? Okay. At least you can type or say something. The next thing, we define something called I cap. This is how we pronounce it, I cap. So this is what? So this is a unit vector along x-axis. So this is how we pronounce it, I cap. Then we write something called j cap. This is a unit vector along y-axis. Then we represent k cap. Oh, this is simply to represent stuff. So there is nothing much on this. It's all, conventions. It's like you're learning the ABC of vectors. So what is this I cap, j cap, and k cap exactly? So Dhruv, I know your cam's not working. I'm asking you, did you understand? So you can reply for that, right? So anyways. So I cap, j cap, k cap. So what does it tell you? So think of like this. It's like a way of giving an address. For example, if I say the point is 3, 4. Do you guys remember we did this in Cartesian coordinates? What is the meaning of 3, 4? It means from the origin, walk 3 units along x-axis. From there, walk 4 units along y-axis. Isn't that how we represent? Right? So now what we can do, right? How do you represent this in vectors? Think of like this. So this vector will be 3 I cap plus 4 j cap. So this is how we write. Again, understand how we are reading this. The meaning of this is 3 I cap. So walk 3 units along I cap. That is nothing but x-axis. Then walk 4 units along j cap. That's nothing but y-axis. So instead of saying walk 3 units along x and walk 4 units along y, mathematically we are replacing all that with two simple alphabets, I and j. You're getting the meaning of this? So I, j will simply tell you which way you're walking. So it just makes it more convenient. So let me show you how it looks. So we define something called a position vector. So much disturbance today, right? So the tail of the vector is fixed at the origin. So if you take a vector and if you keep the tail, the back part at the origin, the head represents the position vector. So what does the position vector do? It simply gives you the position of the point. Okay. So listen to this. So this is important. So this is just like, what we did in coordinates, but it is just about finding address again. AX, AY, AZ. So if someone asks you, what is this vector from O to A? This is how we write, everyone. Listen carefully here. O, A bar. See, how are we writing this? O, A bar. And look at the arrow. The arrow is going from left to right. It's going from O to A. So the meaning of this symbol is we are going from O to A. That's it. That's what it means. And how are we going from O to A? So walk AX units. So instead of writing X, Y, Z, I'm writing AX, AY, AZ along x-axis. From there, walk AY units along y-axis. From there, walk along AZ along z-axis. So this is what it means. So when someone writes AX I cap, it means from origin, walk AX along x-axis. So if instead of writing all the statement, it's a mathematical way of saying I, j, k will just reduce the number of words you're using. Makes your life easy, nothing much. Walk ay along y-axis. So that is how we can think of azk is walk along z-axis.
Sir,
Yeah.
is AX the magnitude and I cap the
Ax is
direction?
yeah. That is how you take it as. So I could give you numbers, right? 3, 4, 5. So 3i, 4j, 5k. So all clear what is the position vector? So position vector is simply a way of giving the address. It's again nothing new. You already know the coordinates, but this is how we represent in a vector form. So if instead of saying how to go from O to A, I will tell you like this verbally. From origin, walk AX units along x-axis, AY units along y-axis, AZ along z-axis. Looks very lengthy, right? So what people said, let's not say every time walk along x, walk along y, walk along z. Let's simply say ijk and I'm done. Ax I cap plus a by j cap, az k cap. It's understood, you and I, that you're walking ax in I cap, ay in j, and az in k. Is that clear, everyone? I hope everyone understood what is ijk now. Right? So ijk is simply the telling you along x-axis, y-axis, and z-axis. If you go in negative x-axis, we call it minus I. If you go negative y-axis, we call minus j, and if you go negative z, we call minus k. Any doubt so far on ijk? Clear? I know this is a little basic theory stuff. Don't worry, we have some pretty deadly ones coming up. Then, how to get the magnitude? So we got OA bar is AXI cap, AYJ cap, and AZ K cap. Perfect. So if I put mod of OA bar, remember this is the magnitude. We can simply use the distance formula. And it looks like this. So root over, you can see I ka coefficient, AX square, J ka coefficient, AY square, and K ka coefficient. You can simply take the coefficients of this and finish it off. Now, be careful here. If I suppose someone writes 2y plus 3j, don't write it as 5. Again, try to understand the meaning of 2y plus 3j. Think of like this. If I give you 2 apples plus 3 oranges, what do you have? Do you have 5 apple or orange? Did you create a new fruit? No, right? So it's like 2 apples and 3 oranges. That's it. You don't add them. You can't do anything with them. Right? This is your magnitude. Then how to get OA cap? Remember, OA cap is a unit vector. So how do you get a unit vector? Take a vector and divide by its own magnitude. So if you take a vector 20 kilometer east and divide by 20 kilometer, it becomes east. So it becomes a unit vector. So in this case, it would be AXI cap, AYJ cap plus AZ K cap by divided by its own magnitude. So if someone asks you to find the unit vector, that's what you do. You take a vector and divide by its own direction and you get a unit vector. And these unit vectors are important because they give you the direction of the vector. They tell you which way you're traveling. They don't care about the magnitude. Unit vectors gives the direction. Example, if someone says, I'm walking 20 meter north. So for this, the unit vector will be (20 meter north by 20. So you get north. That's just a direction. So 1 meter north. All clear with this? But now every time you won't walk from origin, right? We don't want to walk always from the origin. What if I want to walk from somewhere to somewhere else? So I'll write down the next formula. If you want, you can copy that down. That's more generalized than this one. So what if you want to travel from a random point A, which is AX, AY, and AZ, and let's say this is B, which is BX, BY, and BZ. So what if you want to travel from somewhere to somewhere? So if you want to go from A to B, this is how I write the vectors here. A, B bar. So it's telling you I'm going from A to B. So you're going A to B, A is initial, B is final. So what is final here? Bx. So you take final minus initial. So Bx minus Ax. Remember, you can subtract only x's together, y components together, and z together. So this would be By minus Ay and Bz minus Az. So this is simply a way of telling you how to go from A to B. So this vector, when you say AB bar, it is telling you from A, walk Bx minus Ax along x-axis, right? And walk By minus Ay along y-axis, and walk Bz minus Az along z-axis, and you will reach B. So always think of like that. Whenever you get confused, what is this I, J, K? Think of like this is a way of giving you an address how to go from one location to another location. So if someone asks you what is AB bar, you simply take B and A and just subtract them. So A is initial and B is final. We always subtract final minus initial. And you can notice this, we can open this up and you will see this is Bx plus Bx I cap, By j cap, and Bz k cap minus Ax I cap plus Ay j cap plus Az k cap. But if you notice, this is nothing but O to B, and that is nothing but O to A. So don't worry too much about that. That we will see again. But if you see, it is nothing but O to B minus O to A will give you AB bar. So I'm just showing you this. Don't worry. We will talk about this again later on. But this is the red one. The one in the red box is more important. If you don't know that already, you can note it down. We will need it. How do you find the magnitude of AB bar? Coefficient of x, coefficient of y, coefficient of z. Basically, if you think about it, it is nothing but the distance formula. Bx minus Ax whole square, By minus Az whole square, and Bz minus Az whole square. And how do you get a unit vector? AB cap. Take a vector AB bar and divide by mod AB bar. So you take this whole vector and divide by this one and you'll get a unit vector. There. So this is a way of telling you how to walk from one point to another point using vectors. So if someone tells you AB bar is 2y minus j plus 3k, the meaning of this is from point A, walk 2 meters along x-axis. From there, walk 1 meter on the negative y-axis and walk 3 meters along z-axis. You'll reach B. That's it. That's what the whole vector is trying to figure it out. Is that clear, everyone? There, have a look at this. So if you're going to play with this today, quite an important thing. Vectors and all this stuff will keep coming. Like I said, vectors is simply a tool, right? No one will ask you these questions directly. It will be mixed up with some other chapter and something else, and then it pops up. All clear? We can go ahead. You want, you can copy down things in the red box. We will need it. Any doubt so far? You can ask me anything that you're not convinced or not clear here. What is I? What is J? What is K? Did you notice something here? There is not a single number on this page. And that is how it looks as you keep going on. Numbers will start decreasing. And when you're in engineering, right, you'll have courses where you'll not see a single number for the whole semester sometimes. Great. So let's see a question. Our standard cube here. This is your x-axis, y-axis, and z-axis. This is a cube of side A. This is your origin, 0, 0, 0, 0. This is point A. B is your face center. C is the midpoint of this side here. D is the cube center. This is point E. That is again another midpoint there. This is F. The F is again another face center. Great. So I want you to find AE bar, BC cap, FP cap. Yeah, let's get these three. We didn't use D, no? CD cap. Let's get these four vectors. So we got a cube of side A, right? D is the center of the cube. B is the face center. I hope you know what is the face center there. If you look at in your room, look to the right side. The wall which you see, uska midpoint is your face center. The center of the wall is the face center. So F is the face center of the ceiling. Look at your fan. If you have a fan, that's at the center of the ceiling. So that's your face center. There you got 6 points here: A, B, C, D, E, F. So find AE bar, BC cap, FB cap, CD cap. Step one, you need to find the coordinates. How to find the coordinates? We did last time in the Cartesian coordinates. So let's get this. Give it a try. I'll show you the first one in a minute. Okay, let's see the coordinates. First thing, get the coordinates. If you can get the coordinates, your job's done there. Half your work will be done. So let's get the coordinates. How to get the coordinates? I told you last time. It's simply how you travel. So let's say, for example, I want to go to E. So I will go from O to this side. Look at this green thing which I'm drawing here. So I'm traveling along the z-axis. So this point will be 0, 0, A. From there, I'm going up. Which direction? I'm going along y direction. So this will be 0, A by 2, A. So simple, like your coordinates will change depending on which way you're traveling. If you're traveling along x, increase the x coordinate. If you're traveling along y, increase the y coordinate. Going in z, increase the z coordinate. So yeah, from there I can figure it out. If I go from O to here and O to here, and then if I take a turn here, right? So A ka coordinate will be A, A. B ka coordinate will be A, you're going up and coming this way. So that's A, A by 2, A by 2, right? And C ka coordinate will be go straight up and then take a turn. So if I go straight up, that will be 0, A by 2. Someone didn't get the coordinates, please ask me. D is the center, which is A by 2, A by 2, A by 2. And E ka coordinates are 0, A by 2, A. And F ka coordinates are from center, you can go straight up. Right, so that would be A by 2, A by 2. Hope I'm right. Please check your coordinates. The first thing is to get the coordinates. If you got the coordinates, half your work is done. Yeah.
Sir, in this C1, it will be A by 2, na? 0, A by 2, A by 2.
0, A by 2. There is no x coordinate. You're traveling in y and then you're going in z. Done. Where is x?
Oh, yeah. Sorry. Yeah.
There is no x there. Yeah. So you don't need that x coordinate there. So what do you want to find? AE bar, that's the easier one. So AE bar. So you want to go from A to E. So be careful. E is final, A is initial. So 0 minus A. I'll write down 1 for you. 0 minus A I cap. Then A by 2 minus A J cap. So later on we will not write like this. We'll directly write the answer. So you'll get used to it. A minus A K cap. So this would be minus A I cap minus A by 2 J cap plus 0 K cap. So there's no need to write, but fine. If you want, you can put it. Hope that was fine.
Sir, can you show me the previous slide?
This was the previous slide. Questions,
Yes,
okay.
the question.
Right. Then what do you want? BC. So we need BC cap. So we can't get BC cap directly. So let's find BC bar first of all. What is BC bar? You're going from B to C. C is final, B is initial. So 0 minus A minus AI cap, A minus A by 2 plus A by 2 J cap, A by 2 minus A 0 K cap. So what is magnitude of BC? I का coefficient, J का coefficient का square. So root over minus A का square plus A by 2 का whole square. That would be 1 plus 1 by 4. That would be root 5 by 2 into A. And how do you find BC cap? Take the vector BC bar and divide by mod BC. So that would be minus AI cap A by 2 J cap and divide by root 5A by 2. A will cancel everywhere. You'll end up with 2 by root 5 minus I plus J by 2. Please check. That is how you find a unit vector. You find the vector normally first, then get the magnitude, and then divide them. What is the next thing you want to find? FB cap and CD cap. I'll write down here. Can you guys try? I'll give you another minute. You need to find FB cap and CD cap. There. Anyone not clear with anything particular here, please ask. That's it. There's no need to further simplify. If you got till here, you're done. FB cap minus 1 by root 2 minus 1 by root 2 K cap. Okay, let's see. Okay, let's see. So FP cap and CD cap. So let's find FB bar first. So you're going from F to B. So B is final, F is initial, A minus A by 2 I cap. A by 2 minus A by 2 J cap, and there's no K cap there. So mod FB bar will be root over A square by 4 plus A square by 4. That would be A by root 2. So FB cap is simply FB bar by modulus of FB bar. That would be A goes off, root 2 goes up there, and this would be 1 by root 2 I minus J. You can simplify that. So that's 1 by 2 by 1 by root 2. So that's 1 by root 2 there. What is the last one? CD cap. You can check your answers. So CD bar. So C to D. D is final, C is initial. This is A by 2 I cap. Interesting. You should get the same answer actually, because they're actually parallel vectors. So this is 0. This will be a by root 2. CD cap will be, you get the same answer, 1 by root 2 I minus j.
Sir,
Yeah.
in FB cap, it should be minus a by 2 I cap plus a by 2 j cap.
Minus F2B, a by 2 minus a. Yeah, you're right. You're right. I goofed up. Then CD also I must have messed up then. No. CD. Okay. 1 by root 3 CD. No, Ishi. Yeah. How do you get 1 by root 3? See where it went wrong. All clear with this? A by 2 minus 0, a by 2 minus a. So that's minus a by 2. Any doubts on this? All clear with this? So if you see, it's mostly finding coordinates. There's nothing really that weird about it, but yeah, you need to know how to get the coordinates in a cube. So cube is one of the very prominent shape. We keep using it a lot. Any doubts? Can I go ahead? Radhika, clear? Soham? Clear? Shrikant? Clear? Vivek? Clear? Great. Ananya, Ahana, Dave? Ananya, clear? Perfect. Let's see the next one. So we have a particle which is going in a circle. So we have a circle of radius r. So we have a ant here. You can treat this as your x-axis. We can treat this as your y-axis. So t0, we have an ant here which is going with speed u. So as it is going along the circumference, this is your position vector, OA bar. An ant walks along the circumference with constant speed u. Find the position vector OA bar at time t. So indirectly I'm asking, you see, whenever you hear the word position vector, right, simply is asking for the coordinates. If you can find x and y coordinates, I'll just put I cap and j cap as a tail and you're done. Find the position vector OA bar at time t. And then to give you a little more context, think of like this. When the ant is here, this is the vector. When the ant is here, this is the vector. So this vector is rotating actually. So as the ant is going in a circle, the vector OA bar is also rotating. That's not constant. So vector is changing with time. So for different times, I get different vectors. That's it. This is the radius of the vector. Radius of the circle is r. R is the radius of the circle. Speed of the ant is u. After time t, where is the ant? So at t0, ant is at the on x-axis. What angle is this ant going? Not given. We don't know the angle. In case you're getting confused over position vector and all, let me put it more simple. If this is the origin, find the x and y coordinate of the ant after time t. That's it. Simple. Get the coordinates and you're done. So that's how we always think of whenever vector starts looking confusing, go back to basics. Vector is simply x and y coordinates. Answer should come in terms of r, u, and t. Anyone? Any answers? Okay. Let's start like this. After time t, let this ant go somewhere here and let this angle be theta. We have to find theta. It's not given, right? So let this be theta. Nee, Rohit. Great. So if that is your theta and this is your radius r, so from here, if you drop a perpendicular, you can clearly see Cartesian coordinate system. This will be your x coordinate. This will be your y coordinate. All clear now? Right? So this is the adjacent side. So this x coordinate will be r cos theta. Now, remember this thing. Whichever is adjacent side will be the cos theta. Whichever is the opposite side will be sin theta. I hope by now you figured that out. In case you're still confused, you can always write it as sin theta opposite by r, cos theta adjacent by r. Perfect. I got my x coordinate and y coordinate. The only problem is I don't know theta. If I know theta, my job's done. Any ideas on getting theta?
Sir, is it like UT? Because
You can type your answer, Dhruv. If you got it, you can type your answer. So here, you can type it to the co-host here. So if you type it, I'll say whether it's right or wrong. So listen, so how do we get this thing? What Dhruv was saying was something similar. Look at this arc length here. This arc here, isn't that the distance traveled by the ant? This arc length is simply the distance traveled by the ant, which is what? Speed into time. Which is ut. And this is the first thing that I taught you. The angle is nothing but arc length by radius. Arc length is ut and your radius is r. You're done. You got everything. So what's your position vector OA bar? X coordinate, which is r cos ut by r. I cap plus r sin ut by r j cap. Now, when I do this, some people get this doubt, sir, why did you take the acute angle? How do you know it will be in the first quadrant? Why can't the ant go here? Why can't this be theta? Yeah, all valid. But remember this in max, right? We always choose the most simplest one. We try to keep our life easy. Yeah, right, Dhruv. You got it right, Ishim. Yeah, most of you got it now. So keep this in mind. Whenever you have to find angles or something, always take the acute angle. Keep it simple, right? And solve the problem. The equations will take care of themselves automatically. For example, say, for a particular value of time, this angle will become obtuse. So automatically cos will become negative, sine will be positive. So these functions will take care of themselves. That is the advantage of doing with variables. You will get them, the signs will take care of themselves. So don't worry about it. But all clear with this thing? So the main trap of the question is finding theta. That's it. There's nothing big deal about this. I think after I told you how to get theta, then it felt easy, right? It doesn't click sometimes. Any doubts on this? This is an important one because the next one is based on this and that's a little more complex. We are going to build based on this one problem. Any doubts on this? Clear? Next one. Ever played a pen game? You must have played a pen game in school, right? Take a pen, put it on a table and you hit it. The pen starts moving and rolling. So we are looking at the top view. So you're looking this from the top, from a drone or something like that. And there's a rod. This is your x-axis. Now what you did, you hit this thing, and this pen started moving with a speed of 2 meters per second. And at the same time, the rod also started rotating. And this guy is rotating roughly around pi by 6 radians per second. There is a name for this. This is also called as angular velocity or angular speed. Let's keep it simple for now. Think of like this. What is speed? Speed is the distance traveled in unit time. What is angular speed? Angle covered per unit time. Angular speed. That's it. You just put a word angular and it becomes angular speed. This length of the rod is, let's say, we can give you some numbers. So let's say this is 2 meters and 2 meters. I'll explain you more, don't worry. Right, and let's take this point here as A. So A is the topmost point of the rod. The center of the rod initially was at origin. Now when you hit the rod, how do you think this rod will move? Think of like this. The picture will look like this, isn't it? After some time, the rod becomes like this. So if you look at the path of this A, the A will be here. After some time, A will come here. Then after some time, A will come here. So if you see, the A is going like this. Isn't this how A traveling? A is not going in a straight line. A is doing some weird curve. It's going in something like this. So this is how similar to a pen game. In case you're confused, put your pen on the table and hit it and look at the cap of the pen. You can see it goes something like this. I'm sure most of you must be pros in pen games. All right, so a rod is placed on a smooth horizontal table. Right, which translates and rotates. So this thing is going in forward also and rotates also. Which translates and rotates. With 2 meters per second, that is your speed, and pi by 6 radians per second. Try to understand this pi by 6 thing, meaning if you want, I'll give you a little more context. So initially the rod was here. This is the scenario at t is 0. You're going with 2 meters per second and you're rotating with pi by 6 radian per second. Can you tell me how will the picture look in 1 second? If I want to draw the picture at t is equal to 1 second, so in 1 second, how much will you travel horizontally? You will travel 2 meters, meaning center of the rod will be here. And you will cover an angle, how much? In 1 second, you'll cover pi by 6, so your rod will become like this. So this angle will be pi by 6 or 30 degrees. This is point A. And this point will be 2, 0. You're getting how it was looking. Suppose if I want to draw the picture after, let's say, 3 seconds, t is equal to 3, the rod would have traveled a distance of 3 into 2, 6 meters. And the angle covered will be, so here theta is simply pi by 6 into time. So if I put t is equal to 3, I'll get pi by 2. That means the rod has become like this. It has become horizontal. The center of the rod is here. The point A is here. So basically, this thing has covered 90 degrees or pi by 2. I hope everyone is able to understand how the rod is rotating. So that will tell you how much angle it is rotating. right? So if I take t is equal to 6, then your picture will look like this. The rod has completely become reversed. A would be here, and this rod has rotated this full angle, which is pi by 6 into 6, which is pi radians or 180 degrees. Is the context clear, everyone? I hope everyone is understanding how the rod is moving now, right? So what I want you to find, I want you to find the coordinates of A after time t. So initially, the point A is at 0, 2 after time t. So I'm not giving the time. So for different times, what will be the coordinates of point A? Find the position vector of A at time t. I hope the question is clear. Right, Ananya, you can think of like that, like a wheel of a car. This is, I'm slowly developing this because later on you will see stuff like this. Look at this thing. So someone threw a rod into the air. This rod is rotating and translating. So same story. What I gave you now in a straight line. So this rod is going like this and it is rotating. Look at this thing. This is the path. This is how the picture is. So we need to find the coordinates of point A. The same question I asked here. Later on, it will come for us also. Find the coordinates of A at time t. Idea is the same, but yeah, it's a little more complex. But so we are building it slowly. This is what I was saying. Whatever I teach you, everything will keep popping up. So let's get this thing. If you remember the sector angle I taught you first thing, we keep using it. We keep using it. So let's get the coordinates of A after time t. I know the time t and all will look a little weird, but you guys get used to variables. Advanced many questions will be on variables. Variables have an advantage because if you do with time t, I can put t1, I can put t3, I can put t6. I'll get everything directly. Or else you have to calculate for each and every time. So how do we do this? Take a minute or two, then I'll explain a little more. I'll give you a little more context and then we'll see. And again, what did I teach you so far? I taught you only one thing so far. If the coordinates are x, y, z, then the position vector is axi cap, ay j cap, az k cap. That's it. I didn't teach you anything new so far. And this is something which you must have seen n number of times playing a pen game. Now listen, I'll tell you something. This is a very important thing. Okay, in physics, right, we have something called principle of superposition. Right, pretty important concept. What it tries to tell you is, if there are two independent events, right, and event 1 creates effect 1 and event 2 creates effect 2, event 1 plus 2 will create effect 1 plus 2. Right? What do you mean by that? Example, if you take a block of mass m and let's say you apply force F1 and this gives an acceleration A1. If you have another block mass, same mass, but force F2 and it gives an acceleration A2. And if you apply F1 and F2 together, you will get acceleration A1 plus A2 at the same time. This works when there are two independent events. You're getting it? So if there are two independent events, Anish, looks like you got something, but let's see. right? So this is how it works. And it doesn't just stop here. Huh? This thing literally works in multiple places. For example, let's say you have a circuit. And let's say there are two batteries. And this is one of the way how you teach a computer to solve circuits. If there are multiple batteries, the computer doesn't know how to handle this. So let's say there are two batteries, V1, V2 and all, and you want to find the current in the middle branch. So what we will tell the computer, okay, assume there is only V1 ka battery. Forget about the other guy. Assume it is just a wire. Then assume only V2 is a battery. Forget about the other guy, treat it like a wire. So if V1 creates a current here, I1, and if V2 creates a current here, I2, when you add them together, the net current will be I2 minus I1. It works. Circuits, forces, motion, everything. Making sense? This is called principle of superposition. We will not write any proper definition and everything, but you will see this thing will just keep coming everywhere. It's a very powerful idea, right? But again, the thing is this. So I'll write on the statement there. If two independent events, this is the first thing. Event 1 and event 2 should not interfere with each other. Right? If two independent events effect 1 and effect 2, when both of them act at the same time, we get the net effect. So you get effect 1 plus 2. So like this, if you have 10 batteries and each one is getting I1, I2, I3, then when you have all 10 batteries, you get current I1 plus I2 plus IN. Again, not every time it is, if the events are not independent, it doesn't work. For example, you break the TV in the house. Mom comes, takes a broom and starts beating you right and left. Then later dad comes to know you have broken the TV. Now, if these are two independent events, dad also will beat you right and left. But after dad comes to know that mom has already beaten you, he might not beat you that much. So see, they are interfering with each other. I know, bad example, but you got the point, right? So how do we handle this question there? So see here, what are the two independent things? Can I say like this? The problem I'm facing here is the rod is moving and it is also rotating. So it looks a little confusing. So why don't I do one at a time? So first let the rod only go straight. Forget about the rotation. I'll draw a little big. So here the two independent things are translation and rotation. So we will treat them as they're independent things. So we can take one at a time. So first let the rod go in a straight line. So after time t, the rod would come somewhere here. So this is 0, 0. This distance will be ut. So this coordinate will be ut, 0. Now let the rod rotate by theta. And theta is nothing but angular velocity, that is pi by 6 into time. So assume rod moves first, or rod translates first. Because see, it doesn't matter whether you translate first and rotate or translate, the end answer will not going to change. So assume rod translates first and then rotates. That way, right, it makes it easy to see. It's like one straight line and one circle. So this is a motion of, it's a combination of, what? So when you're going with V and when you're rotating, I can treat this as one motion where you're just going straight plus one motion where you're going in a circle. So this motion is a combination of a line plus a circle. Perfect. So this is point A here. This length is 2 meters. So you want to get the A coordinate, so go straight and go to the right. So this is the adjacent side, which is 2 cos theta. This is the opposite side, 2 sin theta. So done, perfect. So you want to get the coordinates of A. how to reach A from the center of the rod. So this is already ut comma 0. So if you go up, y coordinate will increase. If you go right, x coordinate will increase. So the x coordinate of A will be x coordinate of the center. Plus you need to travel extra 2 sine theta. Y coordinate of A is y coordinate of center. So plus 2 cos theta. Therefore, the vector OA bar is simply x center, which is ut, which is 2t. Speed is given how much? 2t plus 2 sine pi by 6t. This whole I cap plus 2 cos pi by 6t j cap. Is that clear, everyone? So one straight line, one circle. That's how you treat the whole thing as. Instead of saying the rod is rotating and moving, which looks confusing, this becomes more easy. I'll give you one more example. Tell me this. If you stand on the sun and look at the moon, if you stand on the sun and look at the moon, can you tell me how the path of moon looks like? If you stand on the sun and look at the moon, how does the path look like? So if you are standing on the sun and if you try to look at the moon, it looks like some jalebi. Isn't it? This is the path of the moon as seen from the sun. It's very complex to study. But if I say this way, stand on the sun and look at the earth. We know earth goes almost in a circle. Now stand on the earth and look at the moon. That goes in another circle. So this motion is nothing but a combination of two circles, isn't it? Making sense? So this weird jalebi motion is nothing but combination of two circles. Principle of superposition. So stand on the sun, look at the moon, right? Then stand on the earth and look at the earth and then earth to moon. So stand on sun, look at the moon, look at earth. That's a circle. Then stand on earth and look at the moon. So it becomes more easy to figure out the position of the moon now. So that we are going to use this a lot. So helps a lot. You can basically take a complex problem and split it into small, easy pieces, and then you can solve. Yeah, when you look at the moon, it's a path, right? So all clear with this? Go take a small break, come back by 9:46. We'll continue from here. Any doubts so far? Go, take a break, get away from the screen, come back in 6-7 minutes. Dhruv, you're asking something. You're there?
Yes, the starting one.
No, this one I was just saying, like, last time we defined, right? Current has magnitude and direction, but it doesn't and has to obey vector laws. So I was saying current, right, has both magnitude and direction, but it doesn't obey vector laws. So what is vector laws? For example, if you have a force 10 and force 10, they will cancel out, you get 0, right? But if I give 10 ampere and 10 ampere current, I don't get 0 current, I get 20 ampere current. So current is not a vector. Got it?
Sir, but what about the area as a vector quantity? Like,
so area is a vector quantity, like I said, right? We have defined area as a vector because it is more convenient. Because defining area as a vector, right? For example, if you have a house and if you have a door, if I say door is a vector, matlab dekho na, whoever comes out of the house is positive. If someone goes into the house, it is negative. I can define a direction, right? So it becomes more useful to define area as a vector. So what is that use and all? We will see later on. So, but for now, just know that defining area as a vector is more useful. Right? So that's it. So that was just an idea there. So we will discuss in more detail later on when it comes.
okay, sir.
ठीक है, बस वही हुआ था और कुछ नहीं था.
सर और इसके पहले वाला जिसमें वो टेंसर्स एंड वो सब था, कैन यू शो दैट स्लाइड वंस?
No, that is just definitions था here.
नहीं, इसके बाद वाला।
यही है रे।
अच्छा, so you didn't explain tensor that one.
टेंसर है ही नहीं पोर्शन में।
Oh,
वी डू नॉट स्टडी टेंसर्स। ठीक है।
okay, okay.
या So, cams on everyone. Next up. So you must have seen this. Let's say you're in an elevator. Ever seen this elevator car? You have a fan also. So we have a fan. So we have the wings. So we have an elevator here which is going up with speed u. This is the speed of the elevator or lift, whatever you want to call. At the same time, inside the elevator, you switched on the fan. The fan is also rotating with some numbers. I can give you something, let's say pi by 3 radians per second. Right, for simplicity, we can, let's call it maybe some omega. That's a symbol. Instead of numbers, I'm giving you variables. So omega radians per second. So this is the scenario of a rotating fan inside a moving elevator. Can you tell me how will the path look like? If you take any point on the fan, how will the path look like? Again, principle of superposition. So two things are happening. Lift is moving, fan is rotating. So don't look at both of them together. Look one at a time. Suppose if the fan is switched off and the elevator is going up, how will it go? It will go in a straight line. Suppose if the elevator is switched off, elevator is not moving, but the fan is switched on, how will it go? A circle. Now, if you combine both of them, then what do you see? So this is a combination of a straight line plus a circle. What you will see is a helix. The DNA structure is a double helix. So what you see is a helix. So this shape, what you get is a helix. So if you choose any one point here, somewhere, point A, this is the path of A. It's a helix. We will talk about helix later on again, but that's a rough idea there. So this is the path of a line plus circle. The previous one was also a line plus circle, but yeah, it's different. So this is perpendicular. So the question now. So that's the all introduction story and all the story they'll tell you, and others do keep your cams on. So now if you look at your fan, so this is one of the wing. So initially the fan ka center is at the origin 0, 0, 0. This is point A, which is r, 0, 0. R is the radius of the fan. This is your x-axis. This is your y-axis. This is your z-axis. So up and down is z, left and right is x, and front and back is your y. Right, and the fan is rotating with omega radians per second. So every second it is covering omega angle, and the lift is going up with speed u. Find the coordinates of A after time t. Find position vector of A at time t. Again, end of the same story. If you can get the coordinates, you'll get the position vector. I hope the context was clear, right, everyone? So initially that OA is on the x-axis. So the fan is rotating with omega and is going up with u. Are the variables confusing? Should I give you numbers? So if someone is confused with the variables, I'll do with variables, but if you want, I'll give you numbers also. Let's say this is 3 meters per second. Let's say omega is pi by 4 radian per second. And you can say radius of the fan is 1 meter. If you want numbers, those are the numbers you can do with it. These position vectors become quite useful later on when we do something, right? Finding distances, we have to use something called integration. So then we need this vector and we have to integrate and get distance. Yeah. So we are getting the ingredients ready for all the stuff which comes in the future. But again, all these things you have noticed in life, right? Real life. Must have never thought about it. So the path of the point on the fan in an elevator is actually helix. You can say screw. Screw is another good example. Screw ka threading is also an helix. Anyone got anything? R cos pi 4r sine 3t. That looks right, Karthik. Again, like I said, let's split this into two parts. Let's move one at a time. First, let the fan go straight and let the fan rotate. Don't do both at the same time. So initially the fan was somewhere here. This was point A. So the fan goes straight up. So after this would be how much? Ut. So this coordinate will be 0, 0, ut. So if the fan is not rotating and if it just goes up, this is how it looks. So A also will just go straight up, right? So that will be r, 0, ut. But great. Now let's see the fan. Okay, let's see the top view. What is the top view? You can think of, just look at the fan on your ceiling. What do you see? You will look at like this, right? I'll just draw A ka thing. Okay, so this is the A ka blade. So after some time t, the blade will rotate somewhere till here. A will come somewhere here, and this angle will be theta. This is exactly like the previous question now. So from here, when you drop a perpendicular, now understand this will only give you your x and y axis. So this is x, this is y. So you're looking at the fan from the bottom. So there is no z, you're only seeing x and y. This would be your x coordinate. This would be your y coordinate. This was your radius r. So y is nothing but r sine theta. X is nothing but r cos theta. So this is pretty straightforward. Like now, if you got the superposition, you're done. And theta is nothing but omega t. There, you got everything. So when this fan rotates from here, like this, A will come somewhere here, and this will be theta. So this is that rotation. The fan will go straight up and then rotate. And then from here, you drop the perpendicular. So this gave you your x coordinate and this gave you your y coordinate. I hope you can see the picture there. So then you're done. So the coordinates will be x is r cos omega t. You can substitute the values. Y will be r sine omega t. Z will be ut. So the position vector OA bar r cos omega t I cap, r sine omega t j cap plus ut k cap. Any doubts on this?
Sir, what is omega? Like basically what's omega?
That's pi by 4 radian per second. That is angular covered per unit time. This is what we discussed, right? That is angle covered per unit time.
Angular speed, angular velocity
Angular speed.
per unit.
Yeah. Yeah. It tells you how much angle you're covering per second. So I just gave some variable, but its number is given, pi by 4. So every second you cover 45 degrees. So in time t, you cover pi by 4 into t. All clear with this thing, everyone? Any other doubts, any other confusion with the coordinates, please ask. If you see, we're still actually playing with the coordinates only. If you can get x, y, z, you're done. But is everyone clear with the principle of superposition? If you just try to look at the fan car motion, it looks like a helix. This is very difficult to study directly. But if you treat this as one line and one circle, it suddenly becomes easy to handle as. Any doubts? All clear with this? Soham, Tanmay, Vivek, Radhika. Clear? Okay, next one. We got a wheel rolling on a floor. So let the radius of the wheel be r. And A is a point on the circumference which is initially touching the ground. You guys should definitely, after the class, right, tomorrow, take a rough paper and try to do all these questions. When you're listening for the first time, you feel like, I understood. But you take a rough paper and try to do it again on your own. Most of the times you'll get stuck somewhere. That is the important thing. When you get stuck and then when you try for 2-3 minutes and you're struggling and then you go and refer, then you have a reason to remember. So don't think like, I explained and you understood. You're like, oh, I got it. You didn't get it. I did all the work. This is still not your problem. Only when you try on your own on a rough sheet, take a rough paper and just try to solve it again later on, right? So, and this is important. Please do that for every class for the next 1.5 years. So we have a circle here. So this thing is rolling on a floor without slipping. So after some time, the picture comes like this. So A has come somewhere here. You can take this initial point as origin. So this A won't be here. So if you look at the path of A, right, it looks like this. If you ever seen a wheel, when you're going on a cycle, and if you look at any point on the wheel, you will see it's actually going, it's jumping up. It looked like this. Where is this? There. This is how it looks, everyone. There. This is point A. So when the wheel is moving, the point A is going like this. This is not a semicircle. This is called a cycloid. Looks like semicircle maybe, but it is not a semicircle. This is not a semicircle. So the name of this curve is called a cycloid. It has some pretty interesting properties. What are the properties? This. Let's say you want to send a ball from A to B, right? You can draw different paths. You can put a straight line. You can put a in plank, right? You can put a circle. Maybe you can put something like this, vertical drop and then horizontal. And you can put a cycloid. And what people found out, when you leave 4 different balls on these 4 different paths, the one on the cycloid will always reach first. Because see, from A to B, when you leave a ball, if you have a ball, right, if you put an incline, the ball will roll and go. Right? I can put a circle also. And I can even do something like this. I'll put a straight pipe and then I'll put a small smooth curve here and then I'll make it horizontal. So among all the different possible paths from A to B, the cycloid is the path where if you create a track with the cycloid and if you leave a ball, that will reach the point to be the fastest. That's a property of a cycloid. Like that's one application there. So think about it. Tomorrow, let's say you're loading some luggage or something into a ship and you're going to load it from here to here. Don't you want to make a cycloid there? Don't you want to fill the ship faster? Right? So even if you save something like an half second for every 1 kg of coal or something, whatever, that end of the day puts a lot of time. But you're getting how is this ball going here? This is called a cycloid. We will talk in more detail later on about this, but there. Till now you have seen already how many different shapes? You have seen 3 different shapes. You saw the jalebi, you saw the helix, you saw the cycloid. Right? Now, a little more context. Now, if you take a wheel and if you roll it on a floor, so let's do something here. Let's say A to B. So take a color and paint A to B with red. Then let's say B to C, paint with some green color. C to D, paint with some black color. And D to A, play again with some this blue color. Perfect. Now, if you take this wheel and roll it on the floor, what will you see? The first color you will see is A to B. It will be red on the floor. Then the next color you will see be the green color. That will be B to C. Then the next color will be the black color, B to D. Then the next color will be this guy, back to A. So when this thing completes one revolution, you can clearly see the center of the wheel travels a distance of 2 pi r. Quite an important property. This is how your Activa or your scooty or your car knows how much it has traveled. There is a sensor on the front wheel. Next time when you see an Activa, right, look at this. On the front wheel, there are 2 wires. One is a brake wire and one is a sensor for the speedometer. So the sensor will count how many times your wheel is rotating and multiplies that by 2 pi r. That will give the distance traveled by your vehicle. Did you ever see this thing in your school, right? If you ever had this, racing event or any, a marathon kind of event or anything, did you ever see how they measure the length of the racetrack? They don't take a scale and measure the racetrack. They have a setup like this. They have a wheel here and there is something here and they roll this wheel on the floor. As they roll the wheel on the floor, you have a speedometer there. So that measures the distance. That is how you measure the distance on a road. You just take the wheel and keep rolling on the floor and the number of revolutions into 2 pi r will give you the distance traveled. Right? Imagine you ever seen someone measuring the length on a road with scales or something? Maybe if you're measuring 5 meter, 10 meter chalega, but what if you want to measure 10 kilometer ka, marathon ka track or something like that? So especially when you go for these road races, right? Marathon, half marathon and a full marathon, 42 kilometers. So how do you measure it? So you have a machine like this, which you just roll it and you measure it. So this is one important thing there. So in one revolution, the center of the wheel travels 2 pi r. There. So that's the main idea there. So now the question, find the position vector of A after time t, or when it is rotated by angle theta. So when the wheel is rotating, it has rotated by an angle theta. So find the position vector of A when the wheel rolls by theta. Like I said, always keep theta as acute. You don't worry whether theta is obtuse and all. Don't worry about it. So keep it simple. So find position vector of OA. Let's assume it is still acute only. Find the position vector OA bar when wheel rolls by theta. So your answer should come in terms of r and theta. In case you're still confused about the picture, see, it is how it will be, everyone. So this is what I'm asking. Huh? This is the position vector. Look at the green line. After some time, this is the position vector. After some time, this is the position vector. After some time, this is the position vector. You can see. So from the initial position, you keep joining Eka vector. So as time passes, the vector is continuously moving up and down, up and down. Anyone not clear with the question, anything, any data point you didn't understand, please ask me. This is how they'll ask position vectors. They'll not give you X, Y, Z and ask find position vector. That cube thing which we did, right? That was like, when you go to a restaurant to eat food, remember in the beginning they'll come and put some, onions and lemon. It's like that. That is not even starters. This is main course. So if you want to compare with your lunch or dinner, that's how it looks. So how do we even start? Think. I'll give another minute, then I'll tell you something more, and then you might get even better ideas. So I said if you complete one revolution, you will travel 2 pi r. But what if you travel only theta? Unitary method, right? If you travel only theta, then think of like this. For 2 pi angle, for 2 pi radians, the center travels 2 pi r. For theta radians, the center should travel how much then? R theta. Hope you figured that part out. That means, indirectly what I gave you, I said this distance here, the one I'm marking in red here, this length is r theta. Is that making sense? That is the thing. So if you have completed one full revolution, then theta will be 2 pi, then you get 2 pi r. That's your circumference. So in the circumference formula 2 pi r, what is this actually? This is 2 pi into r. That 2 pi is your radians, that is your angle, arc length. So if you cover only theta angle, then it will be theta r. If you complete 180 degrees, then it is pi radian r, and so on. So this length is r theta. That is the thing there. I think now you'll get it, I guess. So for a full 360 degrees or 2 pi radians, both are same. It's like saying 1 kilometer or 1,000 meters, both are same. It is just the units are different. You will travel 2 pi r. For theta, you will travel r theta. Now get it. R theta. There is no need to let 180, Ranish. R theta, that's it. Theta is done. Remember arc length R theta there? R theta in a sign. No, that's the right issue. You got it. You also got Anish, बस वो 180 नहीं चाहिए था. Okay, great. Let's see. So how do we handle this? So if you travel an angle theta, then you will travel a distance of r theta. And this point ka coordinates will be r theta, comma 0. All clear with that? Now from here, this is your radius r. From here, you're dropping a perpendicular. So in this triangle here, you can clearly see this distance here will be r cos theta. That's your adjacent side. This distance will be r sine theta. That will be your opposite side. I hope all clear with that triangle there. This is a 90-degree triangle. And then you're done, right? You got it clearly that you can clearly see the coordinates. So you're traveling like this, like this, like this, and like this. So that's how you're traveling from origin to point A. This was r theta. So you're traveling r theta up. Then you're traveling, what is this distance then? If that is whole r, this is r, then this distance will be r minus r cos theta. So then you're going up r minus r cos theta. Then you're going back r sine theta. So you're going back again. So from this, we can get the coordinates. So OA bar will be the x coordinate will be r theta forward minus r sine theta because you're coming back, I cap plus r into 1 minus cos theta j cap. Check. Those are your coordinates, everyone. Quite a good problem, this thing. You will see this thing again in rotational mechanics. You will see this again in magnetism, the cycloid. We have some pretty good advanced level questions on this later on in magnetism based questions. Clear this? You will see this cycloid at least 3 to 4 times. But again, if you say it is all about finding the coordinates, all clear with this. Let's do one more easy one. So this is all good, but any doubts on this? So the main thing is to figure out that you will travel r theta horizontally. I think after that it was easy to figure out. So this is the idea there. So this you should know. Now you know. Let's do one more. Let's say we have vector a bar, which is 3i 4j plus 5k. So b bar is xi minus j plus 2k. So this vector a bar is rotated by an angle theta. How much? Not given. How did they rotate? Nothing we know. They just rotated by some arbitrary angle theta. And it becomes b bar. Find x. So the b bar is xi cap minus 1 j cap and plus 2k cap. There, this would be a CET level question maybe, or a mains may be an easy question. I won't even say it's a mains level question, but yeah, give it a try. Yeah, at your level, it is still a good question. But when you're in 12th, this is nothing. So as you keep improving, the level of the questions will keep changing. What might be an advanced question for you now will be an easy question later on. So we have a vector a bar. Someone rotated the vector, it became b bar. How did they rotate? How much they rotate? We know nothing. But the b bar is xi cap minus j plus 2k. Find x. Right, Anish? Plus or minus? We have one answer. Who else? Right, Prisha. We have two answers. Karthik, plus or minus Karthik. So, what is the catch? Tell me one thing. If you stretch your hand and point towards north, okay, stretch your hand and point towards north, then point towards east, then point towards south. When you're doing this, what doesn't change? Your hand ka direction changes, but your hand ka length doesn't change, isn't it? The length of your hand doesn't change. So the main idea is that. So if a vector rotates, the magnitude doesn't change. The direction changes. If the vector rotates, the direction changes, but the magnitude remains constant. That's the main idea there. So the magnitude of a bar, that is mod a bar, remember the meaning of the symbol? Mod means magnitude, must be equal to magnitude of b bar. How do you get the magnitude? I ka coefficient, j ka coefficient, k ka coefficient ka square and add them. So this will be root over 3 square, 4 square, 5 square. You can just take the coefficient ka squares. I ka coefficient is x square minus 1 ka square plus 2 square. You solve this, you get x is equal to plus or minus root 45. You can simplify further, plus or minus 3 root 5. There. Easy one, but there. All clear with this. That's it. The main thing is to figure out that the length doesn't change. If it clicks, great. Doesn't click, now you know. Any doubts on this? All clear? So then when does a vector change here? So I can just put a note here. So if you have vectors like this, let's say if this is a bar, if you move the vector forward, it is still a bar. See, if you're pointing your hand to the right and if you go forward, you're still pointing to the right. So if you move the vector parallel to itself, it is still pointing in the same direction. So you can move vectors anywhere you want. It doesn't matter. If a vector is displaced parallel to itself, it doesn't change. So vectors can be moved around for your convenience. It's okay. It's simply telling you the direction and the magnitude. If a vector is displaced parallel to itself, it doesn't change. It remains same. Clear? And then we have types of vectors. So there's a little more theory there. Next class, we will do something called resolution of vectors. We have some really good ones on that, equilibrium problems, but little more theory before going ahead. So what are equal vectors? They're nothing. It's two vectors of same magnitude and direction. So basically they're equal. I don't even know why they have this definition, but they do have. If two vectors are same magnitude and same direction. Zero vector or null vector. This is important. This will keep coming few times. So zero or null vector. Basically, this is a vector with zero magnitude. And this is interesting. Right? It has an undefined direction, meaning the direction could be anything. And we write this thing as 0 bar. Now, this is important, see. Why is my face stuck? Okay. So 0 bar. You're able to hear me, right, everyone? I think my laptop freezed a bit, but yeah. So, for example, if I say like this, if I say 2 minus 2, this is 0. But if I write 2 cap minus 2 cap, you can't say 0, you should say 0 bar. When you subtract two vectors, what you get is a 0 vector. You don't get a magnitude. So this thing tells a lot. If someone tells you, right, those two things got cancelled out and I got 0. If I say like this, those two things got cancelled out and I got 0, I will assume you're talking about two scalars. But if you tell me those two things got cancelled out and I got a 0 bar, then I understood the two things you cancelled are vectors. Right? It might not look like a big deal, but tomorrow when you publish your research paper or something, you have to follow the conventions of the scientific community. If you write like, two forces got cancelled out and we got a 0, they will just send your paper back and say, boss, do the corrections and send it back. Right? Because if you publish a paper, the guy in Australia or the guy in Europe or somewhere, they should be able to understand what you're writing and what you're talking about. So they have certain rules which you have to follow. So we do that thing. And what are parallel vectors? So parallel vectors, you can see the word, it simply means the direction is same, the magnitude can be anything. So if two vectors have same direction, we say they're parallel vectors. So if I travel 10 kilometers east and if you travel 5 kilometers east, we are parallel. Magnitude need not be same. So we can write A bar is equal to K into B bar, right? So K is a positive number. So since the direction is same, you can say A cap is equal to B cap. Unit vectors are equal. Because if you remove the direction, I travel 10 kilometer east, you travel 5 kilometer east. So my unit vector and your unit vector must be same.
So in this
So
case, is K a scalar quantity?
I didn't put bar no on top. I just wrote K. That's a scalar quantity, right? Then. So we put K into A bar. So if I put K bar, A bar, then you should be outflow. K bar is a vector. No, remember scalar representation. So if you put K bar, so example, let's say A bar is 2y plus 3j. Someone comes and tells you B bar is simply 4 times 2y plus 3j. Both are parallel vectors. So your A bar is 4b bar. And if your K is negative, then we say anti-parallel vectors. So A bar will be KB bar. You can say something like a negative. K is a negative number. So if this is A bar, this would be like minus 3A bar. Both are anti-parallel. Clear with this? Great. So let's do one question on this. Last one for the day.
So can you show
You're
the
tired
last
already.
slide?
Yeah. Yeah, still, this is your main convention there.
Yeah, done.
So let's say we have vector A bar, which is 2y plus xj minus 3k cap. And let's say B bar is 4i plus j plus yk cap. And it is given A bar and B bar are parallel vectors. Let's call it Z. Let's call this thing y. Find y and z. So a bar is 2i plus yj minus 3k. B bar is 4i plus j plus zk. And it is said a bar and b bar are parallel. How will you find y and z? Manish, I think first one we have two different answers for that. Karthik and you got different answers. Second one, Z is fine. I think why you got different answers. Fine, Nadru. Exam, who are you going to ask? I'm giving you time to think. So get a wrong answer. That is completely fine. Ishi, you got okay. I think you might be right, Ishi. I think Anish got the same thing. Karthik corrected it. Okay, got it. Others, anyone else? I'll give another 30-40 seconds. Let's see how can you figure it out. Remember, what are parallel vectors? A bar is KB bar. Bus, that is the main idea there. Yeah, their unit vectors are equal. You can do that, but that won't help you here because there are two variables and you have only one equation. Unit vectors are equal is fine. Nothing wrong with that, but unfortunately, that really won't help you much here. Okay, let's see. Think of like this. So if A bar is equal to KP bar, can I say like this? So 2i plus yj minus 3k is equal to k times 4i plus j plus zk. So basically you have to compare the coefficients of I on both the sides. Remember, like I said, think of like this thing. This is like 2 apples, y mangoes, and 3 watermelons. You cannot add apples to the oranges there. So this is 4k. So apples only must be equal to the apples on the other side. Mangoes must be equal to mangoes on the other side. Watermelons must be equal to watermelons on the other side. As simple as that. So that's how you can think of zk k cap. So this 2 and this 4k must be equal. So 2 is equal to 4k. So that gives you k is equal to half. This y and k must be equal. So y is equal to k. So y is equal to half. Minus 3 and z must be equal. So minus 3 is equal to zk. But I know k is equal to half. So z is equal to 6. Clear? So there is a general way of writing it. So you can write it, remember, like this if you want. So if you have two vectors, a bar axi cap plus ayj cap plus az k cap, and if you have b bar is bxi cap, byj cap, and bz k cap. If a bar and b bar are parallel, then the coefficient ka ratio must be same. Then ax by bx must be equal to ay by by equal to az by bz. That's a simple thing to remember if you want. All clear with this? Parallel vectors, that's an easy stuff there, but that's still a decent question. They do ask questions like this in CET. They do come because in CET, right, we have 150 questions in 3 hours. Means it is only 75 questions, so the difficulty drops a lot. Okay, so that's a bit about different types of vectors. So next class when we catch up on Wednesday, we'll continue from here. We are going to talk about something called a pseudo vector, right? That's a little small discussion there. And then we'll go for something called resolution of vectors and equilibrium. So those will be some really good problems. The equilibrium one is the most important thing you need to study in vectors there. Okay, with that, we'll wrap up for the day. And please make sure to try these problems again. Tomorrow, maybe when you get time, half an hour, take out a rough paper and try to resolve the questions. That's how you revise the notes. You don't read the notes like a novel. That doesn't help. When you revise notes, you